Right, Mr. Lewis? It is time for video number 90.
Yes.
Okay, what do we got?
We have a couple examples to go over hypothesis testing again, just to make sure we kind of got it.
So nothing,
or are getting it.
Nothing new
say.
today.
No.
That's cool.
No.
All right, so just practicing.
Okay, so our first example, a CEO of a large electric company claims that 80% of his 1 million customers are satisfied with the service they received. So to test this claim, a local newspaper surveyed 100 customers using simple random sampling.
Awesome.
Among the sampled customers, 73% said they were very satisfied.
A little bit low.
Right, so we want to kind of do some hypothesis testing to see if we can reject the CEO's claim that 80% of his customers are satisfied.
Okay.
So, here we go. So, here's our everything we need to find. Right,
We're getting
here.
better at this, all
We
right?
are.
So we're just asking for the basic steps.
Right, so state the hypothesis. We have H naught and HA.
Cool.
Okay, and so our original thing would be that our proportion is equal to 80%.
Right.
Okay, our alternative would be that the newspaper found it was lower than that, so we think it's actually lower than 80%.
Okay, it's a one-tailed test.
Right.
So it's less than or greater than one tail.
Mm-hmm.
Okay, find the value of Z.
Okay.
We might want to use some space below for that. Or I don't know, it's up to you.
Well, first we got to find the standard error, right?
Right? Or so actually this would be standard deviation.
Well, standard deviation, whatever.
Because we're using P.
Right.
Okay. So it would be 0.8
0.8
times 0.2
times 0.2
divided by 100.
divided by 100.
So
Actually, it wouldn't be using the 0.73 because that was
Ooh.
the sample.
no, because we're assuming that the true proportion is 0.8.
Okay.
So
Go on there.
so we're assuming the null hypothesis is true.
Got it.
And so p hat should be distributed around 0.8
All right.
with standard deviation. You made me look though.
I did.
All right, I get 0.04.
Okay. 0.04.
Okay, so z is going to be
So Z equals
point.
0.73.
Yep, the value we observed minus what we'd expect if the null hypothesis is true.
All divided by 0.04.
And the z-score is negative 1.75.
Bam. Okay.
Already, I got a hunch that we're going to fail to reject, but we'll see how it works out.
Well, you never know.
Okay, so not that unusual, but we'll see. So find the p-value.
Okay.
So z has a standard normal distribution,
Mm-hmm.
and so the p-value is probability of observing that value of z or less.
Right. So this.
So you gotta know what tail to do.
Or less.
Right.
So your
So
lower tail.
yep. So we'll do normal CDF, and the lower limit.
Is negative a million.
Got it.
Infinity.
Upper negative 1.75.
Deviation or mean 0. 1.
There's a 4% chance. The p-value is 0.04.
0.04.
Now, how do we tell if that's unusual or not?
Well, we can look at our significance level of 0.05.
And it's less than
And it is
0.05?
less than 0.05.
So this is significant, which means unusual.
Right.
Unbelievable, almost.
Yes.
All right, so we're going to...
Reject.
Very good. So this value was unlikely. If the original hypothesis was true, it's unlikely we observed this.
Yes.
Unlikely enough that we're going to reject.
However, like if you were doing this real world, that 0.04 is pretty close to 0.05. So you might want to do a little more testing to kind of...
True.
I wouldn't say you totally flat out reject it yet.
Yeah, close. All right,
So,
kind of borderline. Now, you would normally have to state your conclusion.
yes. But
So
we're not going to do that.
I just saw this. I'm not going to write it.
Yeah.
But maybe we can say it.
So we'd say, using our hypothesis testing at the 0.05 level, we would reject the null hypothesis in favor of our alternative hypothesis that the proportion is less than 80%. So therefore, less than 80% of the company's customers are unsatisfied.
Okay.
That
Very
work?
good. You fit the context in there, so that's important. So I was waiting for
Yeah.
the context.
Well, first sentence should be whether you're rejecting it, not rejecting it. Second sentence, bring it back to the problem. Is
Very
usually
good.
what I do.
All right. All right.
No.
This is going to be a two-tailed test, so I'm going to do another one of these.
Okay.
So a manufacturer claims that 5% of the goods he produces are defective. If out of 200 items randomly selected from this product, 14 are found to be defective. Check his claim using a hypothesis test at a 5% significance level. So
Okay.
as the original hypothesis is that 5% are defective,
Mm-hmm.
but we want to see if the sample indicates that it's not 5%.
Right. Okay. So here's our
All right.
little thing again.
So
All right.
null hypothesis is P equals 0.05. And the alternative, and again, this is based on the wording of the problem, is simply that P is not equal to 0.05. This is going to be a two-tailed test.
Right.
All right, because we're not favoring either direction.
Mm-hmm.
Okay, find Z.
Okay. So first we need our standard deviation.
Yeah.
So.
All right. So it'll be the square root of 0.05 times
0.95.
Yep.
All over.
100? 200 this time.
Okay. Thank you.
So
couldn't remember.
it'd be 0.0154.
0, 1, 5.
I actually
4.
recommend keeping a few digits here because we're going
Yes.
to divide by this number. When you divide by a small number, that can radically change the Z
Yeah.
value.
A lot of people in the last unit when we were doing some of the normal curve stuff were finding that if they would round their standard errors or whatever, it could get kind of funky.
Yeah, so
So.
leave a few digits in there until we're done.
Mhm.
All right, now we're ready to find Z.
Okay.
So Z, the observed value was 14 divided by 200, which I think is 7%, so 0.07.
Okay. And we are subtracting that from 0.05.
Which would be what we would expect, and dividing it by
0.0154. I know it's going to be positive.
It is. It's 1.29.
1.29.
Actually, one. Yeah, that's close enough.
I'm
Shocking?
yeah, I'm
Unbelievable?
I'm feeling a fail.
Yeah, that's not that shocking.
Okay, so 1.29, we're about here. But again, it's two-tailed. So bottom and upper.
So remember, we're calculating the probability of observing what we observed or more unusual.
Right.
So in this case, it's further than 1.29 from 0.
Mm-hmm.
So it's on both sides. But you just do one of them and multiply by 2.
Right.
So I'll do the lower one, and then I'll times it by 2. So normal CDF, blah, 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 up to negative 1.29. Times 2 is 19.7%.
Ooh, that's a big number.
Fail.
Yes,
That's believable.
it is.
So it's believable that we could observe that.
Mm-hmm.
There's a 19.7% chance. That's not unlikely.
All right. And then how do we interpret this?
Well,
I'm going to let you say it this
I'm
time.
glad you asked. Because our p-value was greater than 5%,
Mm-hmm.
we decided to fail to reject. There is not enough evidence to show that the percent of... Now I got to remember what the problem was.
Was it Democrat? Oh, no. Democrats was the one for the Journal. Yeah, I don't remember either.
Was it? Oh, this is terrible.
Hang on. Well,
it-
we could just scoot back. You guys will just have to remember the work. Oops. Hang on. I went the wrong way.
Yeah, it was that one. Oh, yeah.
Defectives.
Yeah. So...
There we go.
not enough evidence to show that the percent of defective parts is different than what he claimed.
All right. Yeah,
Phew.
we're both getting old. We can't remember anything. All right. So now your guys' turn at the Journal. So this time we have Democrats, as I hinted at a moment ago. So of the 150 Democrats interviewed, 90 favor a proposition. 2 years ago, 65% favored the proposition. So we want to perform a hypothesis test at the 0.05 level to see whether or not the true proportion has increased. Okay, so state the hypothesis, find Z, find the p-value, reject or fail, and then interpret. Sound good?
Sounds good.
Okay. See you guys tomorrow.